Alright, here is our next example of joint variation. And let's go ahead and read the problem, and then we'll talk about it. So it says, if y varies jointly as x and z, and y equals 5 when x equals 2 and z equals 4, find y when x equals 3 and z equals 7. So again, we're dealing with joint variation, which is a type of direct variation. And I'll say again, the only difference is that instead of dealing with one variable, we're dealing with two or more when we're talking about joint variation. Okay? So we want to go ahead and set this up and solve for k. Before we do that, we want to rewrite our direct variation equation here to better fit our problem at hand. So what are we trying to find? Well, we're trying to find y, so y is going to remain as y. And then we'll have y equals k. And then what are our two variables here? Well, it's going to be x and z, right? So x and z. All right, let's go ahead and plug this in now and solve for k. So y, what does it tell us? Y equals 5, right? So I'm going to put 5 here. We don't know k. What about x? X is going to equal 2. And z is going to equal 4. Alright, so doing this out, we'll have 5 equals, well, 2 times 4 is 8. And now we're just going to divide both sides by 8 here, and we're going to figure out what k equals. So if I do 5 divided by 8, I get 0.625. So k, I'm going to write it up here, equals 0.625. Alright? Okay, let's erase this work. And then let's take a look at what we need to do next. It says find y. So they want to know what y equals when x equals 3 and z equals 7. So again, we're going to set this up. Y equals, we know what k is, 0.625. X is going to be 3 here. Z is going to be 7. We're simply just going to multiply this out, and that will give us our answer. So let's see what we get when we do that. So we get 0.625 times 3 and then times 7. And we get 13.125. 13.125. And this will be your final answer right here. Okay, and that is it.